As we move further into geometry, we move into what we call polygons. So a polygon the word poly kind of means many. Gon kind of implies sides. So we're talking about something with many sides. So there's a variety of polygons. So a formal definition, a polygon is a plane figure. Remember, a plane is basically a surface, or like we say, a piece of paper. For most of us, you're just going to be drawing on a piece of paper. So a polygon is going to be a plane figure. So what does this figure actually look like? So again, as we said, a plane is two-dimensional. Okay, it's flat. So when we talk about polygons, they're going to be closed. So that means all the sides are going to be connected. There's not going to be a side that's not connected. So it's going to create a closure. And again, there aren't any curves with polygons. Polygons are made of what we call line segments. So we know what line segments are. So when you generate a polygon, you're going to generate a shape using line segments. So again, when the sides connect, they have to meet only at their endpoints. So these line segments are going to be from endpoint to endpoint to endpoint. So when we talk about these shapes, these polygons, some parts of polygons, we have sides, which are the line segments. The vertices are the corner points, and the angles are formed at each vertex. So two sides and the vertex will create an angle on those edges. So as we move into polygons, the most common type of polygon is what's called a convex polygon. We don't use this word a whole lot, uh, but a convex polygon is kind of more of a generalization. So a polygon in which all the interior angles are less than 180. So every line segment joining any two points inside the polygon lies completely inside the polygon. Okay, so we have that going on. So on these interior angles, all these angles are going to be less than 180. Nothing is going to be more than 180. All the vertices point outward. No part of the polygon caves inward. Okay, there is no caving inward. So any diagonal drawn between two vertices lies entirely inside the polygon. So we'll start to look at some specific examples as we move forward. So the basic thing right now is if you draw a convex polygon and connect any two points on the inside, the line never goes outside the shape. So everything stays within the shape. So when it comes to polygons, the most common type of polygon is, of course, a triangle is the simplest, a square, a rectangle, and then we have another type that is common is a regular hexagon. And hexagon implies the word regular means all sides are equal. Hexagon implies six-sided. So it's a six-sided shape where all six sides are the same length, which is also going to create all six angles will be the same length. So that's a convex. So the opposite of convex, they use the word concave. So in concave, at least one interior angle is greater than 180. A diagonal lies partly outside the polygon. So convex are going to look like these. Notice how we have a closed figure. That's a polygon. And notice how these three angles are all less than 180 when we talk about angles. Notice how, again, if I draw a diagonal, so if I pick this vertex and draw a diagonal across there, it's going to touch over here. It's going to be completely inside. So typically we don't really do diagonals with triangles. You really have to have more sides. So that's really not the best example there. So four-sided and so forth and so on. You can kind of see a little bit more because notice how here we have one, two, three, four vertices. So we have a four-sided shape. So notice when we draw a diagonal, we really go from an endpoint to an endpoint. Notice how this diagonal stays within the uh, the polygon. And since that happens that way, we give it a special name. These are convex polygons. Notice how, if you look at this here, notice this angle here is actually more than 180. So this interior angle, if you will, is greater than 180. Also, if I draw a diagonal from here to here, notice this diagonal is not inside the polygon. So when that happens, this is considered a concave polygon. So we don't really deal with these shapes in our course. Uh, so they're out there, but we're not going. Most of our stuff is going to stay within the framework of convex. So again, we have this. These are more what we call concave. Okay, so let me get this thing to cooperate with this here. So these would be examples of not convex, or we use this phrase concave. Notice how again, it's if I look at this diagonal to there, from here to here, notice that this diagonal is outside the actual polygon. Notice that the polygon is this region here. This is the closed shape right here. So remember, the polygon represents a closed figure. This is the closed shape. But if I connect this point to this point, it does not go inside the polygon, and that can't happen. So if there's at least one diagonal that's partly outside the polygon, then we don't call it a convex, we call it a concave. So polygons are really going to be these simple closed curves, okay? But these curves are really going to be line segments. So as far as some regular polygons, this is what's called a regular three-sided figure or a regular triangle. You know, this is a regular four-sided figure, which we usually call a square. This looks like a five-sided figure, so this would be like a regular pentagon. And this looks like looks like six sides, so that's a regular hexagon. And then eight-sided would be what we call a regular octagon. So some of these shapes you already may be familiar with through passing. So again, the types of polygons we have a three-sided shape is a triangle. The four-sided shape is going to be a quadrilateral. And we're going to spend a lot of time talking about triangles and quadrilaterals. There's a lot of those different variations. A pentagon, hexagon, heptagon, octagon, those are just to name a few of the polygons. So notice that we can go past eight, but right now, these are the most common ones that we see. And we may mainly focus on the triangle and the quadrilateral in our course. So we'll pause here and we'll talk about the triangles in the next video.